And what is the first thing we always want to consider? Factor. Yes, does it factor? Because we would be looking to see if something cancels, right? Right? Now, does that top factor? I believe it does. But nothing cancels, right? Now, the factoring is not, we have not wasted our effort. The factoring hasn't been a waste of time. We're going to use those factors, but not to cancel. So, all right, here we go. Let's start filling in some information here and drawing a picture. Vertical asymptote. Do I have one?
Yep.
Where is it? 2. X equals 2. So on my picture, I draw x equals 2, and then in the little blank that says vertical asymptote, I write the equation x equals 2. All right, do I have any holes in this picture? None. None, not this time. Are there any zeros or x-intercepts? Where are they? How do we find the zeros of the x-intercepts? We put a 0 right here, right? So what happens to the denominator? It goes away. What are the zeros? 3 and -1. They are points, -1, 0, and 3, 0. Those are my zeros. My x-intercepts, remember, zeros are x-intercepts, they are points. Do I have a y-intercept? I do. And how would I find my y-intercept? Don't set it equal to 0. Let x be
Plug in
0. Plug in 0. And so what do I get when I plug in 0? 3/2. So my intercept is at 0, 3/2. Again, the y-intercept is a point. So I will plot it at 0, 3/2. Now, when I wrote the problem, or you looked at the problem, did you notice that the power on top was bigger than the power on the bottom? That means there is no horizontal asymptote, right? But there is an end behavior asymptote. There's always an end behavior asymptote. Sometimes it's horizontal, sometimes it's not. This one is not horizontal. How am I going to find my end behavior asymptote? Patty?
Synthetic division.
I'm going to divide the problem right there. I'm going to divide it. I know I'm not going to get 0. That is not an issue for me. I couldn't care less about that denominator, right? What I care about is right here. What does this say?
X plus 0.
X plus 0. So y equals x plus 0 is my asymptote. Well, that's the line through the origin with a slope of 1. It's actually the identity, right? So there it is. There's my slant asymptote. And now you should be able to draw the picture. If not, we'll have to plot more points. Do you have a feeling for what this thing looks like? Yeah, I think we have plenty up here to tell us what it looks like. These 2 points right here have to be connected. And we'll just follow this asymptote this way. And then what happens here? It follows the vertical one up. And then you've already got this point plotted over here. So that means we're coming down like that and following that asymptote off the page. All right, let's answer some more questions then. All right, number 6. I kind of got these a little bit out of order here. 6 and 9 probably should be answered together. 6 says, what happens to the function as x gets bigger and bigger and bigger? So as x gets bigger and bigger and bigger, what is happening to the red curve? It's going up. So the limit as x approaches infinity of this function is infinity. It just keeps going up and up and up. Now 9 is the same question, only it says what happens when you go the other way? What happens as you approach as x approaches negative infinity? Well, what's happening to the curve, the red curve, as we go this way? It's going down. Now, number 7 says, okay, now let's let x approach 0. Here's where x is 0. What happens to the red curve as we approach 0 from the right? So here we are approaching this is 0. This is where x is 0. I'm approaching from the right. Where is the curve headed as I get closer and closer to 0? What is the y value doing?
Going down.
Going down, getting closer and closer to what? 3/2. So the limit as we approach 0, actually from either side, right? This says particularly from the right side, but from either side, as we get closer to 0 on x, isn't y getting closer to 3/2? All right, then we want to approach 2 from the negative side. Now that's a little bit different because what's happening at 2? I have an asymptote. Now I'm coming from the negative side, from the left side. As I get closer, watch your red curve. As your red curve gets closer to that asymptote, which is at 2, what is happening to the y values? What are they doing? Going up, positive infinity. On the left side of that asymptote, as x gets closer and closer, as you get closer and closer on the left side, your pencil goes higher and higher and higher up. Now, 10 is exactly the same question, but it's from the other side. So what is happening to the curve, the red curve, as we come toward the asymptote on this side? What's happening to the curve?
Going down.
It's going down. Now we want to approach 3 from the left and the right. Well, now wait a minute. What happens to the curve at 3? There's a point there, isn't there? No asymptote. It's a dot, isn't it? Does it matter whether I come from the left or the right? If there's a point there, what happens? Aren't the y values doing the same thing? What are the y values doing? They're getting closer to what? 0. So the answer to these is both 0. Just like when we were talking about approaching 0 right here, what did we say the y values were doing? No matter which side we were on, the y values were getting closer to 3/2. If there's a point there, that's going to be the value of your limit. It's only when there's an asymptote that funky things happen. Okay, well, if we have time, we'll do the back side. There's another one on the back. Look at the back real quick. What's the difference with the problem that's on the back? It has its end behavior asymptote is horizontal. Why is it horizontal?
Because the powers are the same.
Because the powers are the same on the top and the bottom, right? Okay, now we're going to shift gears for a minute, get some learning done today, and then if we we have time, we'll do that other quiz on the back there. Right now, we need to look at some problems in 2.7. This is a really easy section. We talked about it in algebra class. It's all about solving equations. Okay? And the equations all have fractions in them. I know. Ooh, ooh, ooh. Everybody says ooh. The easiest thing to do, and I'm not saying the only thing to do, but if your reaction is ooh, 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 then let's get rid of the fractions. Yeah, you don't have to. The problem is solvable, keeping them. But since most of us don't care for fractions, let's multiply everything, in this case, by x times x minus 3. Now, that's everything in the whole problem getting multiplied by x and x minus 3. Now, what good did that serve? Well, when you multiply this one, you're going to cancel those x's, right? And be left with just x minus 3. Minus, okay, now these are going to cancel, so I'm left with minus 2x equal to, nothing cancels there, so I just distribute it, 4x squared minus 12x. Now, with one easy move, I don't have any fractions anymore. What do I have? A quadratic equation. What do I do with quadratic equations? I move it all to one side, I get it set equal to 0, and then I get to pick, right? Does it factor, quadratic formula, whatever. So if I'm going to move everything over, first I'll collect my terms here. And then if I'm going to move it all over, I'll have 4x squared minus 11x plus 3. Does that look okay? Now, I will either factor that or use the quadratic formula. Anybody see any factoring there?
I think I do. I think I can see it factor.
How does it factor, Addie?
It's a little bit complex, but I believe it factors into 4x.
So I don't think that's going to work. Does 2 work? I think we need the quadratic formula. So here we go. X equals negative b plus or minus 121 minus 4 times a times c all over 2a. Now, what do we got under there? Oh, what is that? Like 70. 121 minus 48. 73. My arithmetic okay? So there are the answers. It didn't factor. There are the answers to the question. Now there is, I'm not worried about it in this case, but there is one little thing you do have to be aware of. In the original problem, you had an x in the denominator and an x minus 3 in the denominator. So that means that whatever happens as you solve, you could not have an answer of 0 and you could not have an answer of 3. Those are called excluded values, and they're excluded right from the beginning, because if x was 0 or 3, you'd be undefined. So right from the beginning, we know those couldn't be answers. Well, it's fine, they didn't turn out to be answers, but if they had, I would have to throw them out. There's no way in this problem you could have either one of those as your answers. All right, that didn't seem so bad, did it? Let's try another one. always look so big and scary, but they're not. What do you think about this? Factor that denominator right? So you can see what you're dealing with here in terms of common denominator. And I'm going to do what I did before. I'm going to get rid of it. So what would you suggest I multiply by this time? X and x plus 4. You need to multiply by both of them, x and x plus 4. Right? And what do we end up with? Well, nothing cancels here, so again, I'm just going to distribute 2x squared plus 8x. All right, now here, these are gone. Oh, and here, that's all gone, right? So once again, we've got our handy-dandy little quadratic. Patty, what do you think about that one?
It might factor up, I might.
It might, you're right. It might, let's see.
So, 8 and 30 multiplies into 24, but adds up.
4 and 3 maybe? 8 and 30.
I'm trying to think here, train of thoughts, kicking.
I think I got it there.
Probably did.
Yeah. Well, I know I did because I foiled it, and when I foil it, I have to end up with this. So I did. Now, if you don't want to factor, though, what option do you have? Will that always work for him?
Yeah.
Yep.
Never fails.
I got 3/2 and -4 as my solutions. But time out. Back in the very beginning, x cannot be 0 and x cannot be -4. Because those two values, we call them excluded values, would make the denominator 0. So this one gets thrown out, and the only answer to the problem is 3/2. That's easy to forget. So sometimes people actually write these down at the very beginning of the problem just to remind themselves. You can't use -4. Okay, is that all right with everybody? Let's try this one. Looks big and scary.
Well, we should probably factor that on.
Should probably factor that thing, yeah.
And I see
Hopefully,
its factors already. It's right in front of us.
Which one is that?
hopefully this will,
Which one is that?
I don't know. I think I turned the page. It's supposed to be 27. Did I copy it wrong?
It's alright.
Alright, so I did what Patty said. I always do what Patty says. I factored this denominator. Alright, now what am I going to multiply through by? X plus 4, x minus 1. Remember, you can only multiply when you multiply everything by the same thing. You can't multiply different pieces by different things. Anna, what's on that iPad? Alright, here we go. We're going to cancel, In the first term, I'm left with 4x squared minus 4x. In the second term, we're left with plus 5x plus 20. And on the end, all we've got is 15. Good grief, there's another quadratic equation. 4x squared plus x plus 5. Is that right? Factoring's not looking good there. So let's see what we have. Oh my. Why am I saying oh my? We have no real solutions here. Now we got an issue. Remember, even if you finish solving this, which I know you all could, and you would get something like, I don't know, 5 plus I or something. Are you allowed to have i's in your denominator? No. So that isn't, their i's are excluded answers. They're excluded roots right from the beginning because we're not allowed to have them in the denominator. You couldn't plug that back in. So no real solutions to this one. Moving on. One more. This is easy. You're not going to have any problems with this. Look on page 254 of your book, page 254, we're going to do a little word problem. All right, let's look at number 33. Don't make it hard. 33. We're going to sell golf hats. We're going to sell them for $2.75 each. 33. It costs us $2.12 to produce a hat, and we have weekly overhead costs of $3,000. What are overhead costs? What are we talking about? People, don't you take econ? All right, overhead costs, and like here at Cathedral High School, overhead costs are the light bill, the water bill, the taxes, the gas bill. Those are expenses you have no matter whether we're in school or not, right? We still have a water bill whether there's school or not. There's water coming into the building, we're paying for it. They're heating or cooling the building whether you're in it or not. Those are called overhead costs. So you have those are fixed expenses, you have them every single month. So for this factory, or whatever it is, they have costs of $3,000. So every month they're paying $3,000. Then on top of that, they're paying $2.12 per hat to actually create the hat. So you understand what's happening? Now, question is, let X be the number of hats. Express the average cost of producing one hat as a function of X. The average cost of producing one hat. What do you think? Well, 2.12, what's the 212? What's that? That's the cost of hat. So if we look at this on a weekly basis, everything's in weeks, right? If we look at this on a weekly basis, X is the number of hats per week, right? Okay. Then we're going to spend, to make the hats, we're going to spend that much money. Would you agree? But what? That's not all you spend. Every week you also have this, right? So isn't this your total cost per week? Okay, now that's your total cost per week. So how much is it per hat? What would you do to find out how much it is per hat? What? No, I don't have an equation.
I thought they just told you that it's $2.12.
Well, it's the materials and the labor cost $2.12. You also have the overhead costs that go into it. That is how much it costs to make X hats. So how much does it cost to make one hat?
And I know.
Exactly, divided by X. That will tell you how much it costs to make one hat. The numerator is how much it costs to make X hats. Okay, stop and think about it for a minute. If you were gonna make 50 hats, wouldn't you take 212 times 50 and add 3,000? That would be your expense. Now, if I said how much is that per hat, wouldn't you divide it by 50? So that's what we're doing, we're dividing by X. This is your cost per hat. Now okay, so that's problem one. Now, we want to break even or make a profit. Well, that means more than break even. How would I figure out how many hats I need to sell to be profitable? Patty? How would I figure out how many, well, this is what's going out. These are my expenses right here. This is my total expense.
I'm pretty sure.
What's my total income?
63 cents.
275 times X? That's how much I'm bringing in. So this is, okay, in here's the factory. This is how much it's costing me to make X hats. Now I'm gonna step out in the hall and I'm gonna start selling them. Every hat they give me $275 for, so now I got this pile of money in my hand. This would express when I break even, wouldn't it? When my costs equal my revenue. Anything after that will become profit, right? So I'm just gonna solve this equation. So 3,000 equals 0.63x. Did I subtract right? And 3,000 divided by 0.63. I gotta sell a lot of hats. About 4,762 hats in order to break even. More than 4,762, that's when I start being profitable. Okay? Not too bad. Not too bad. There's a few more like that. Okay. All right, now we're going to look at a different kind of problem. Those are all pretty easy. We're going to look at a different kind of problem now. Actually, two different kinds of problems. We're going to look at some inequalities. We'll start with the easy ones. So we'll start with something like this. I don't think we did these earlier. Sometimes we do these back in chapter 1. I can't remember. Does that look familiar? I mean, I know you know how to factor it. You know how to factor it, right? And I'm gonna draw a number line. Now I'm not sketching this like the practice quiz we did at the beginning. There's no Y in here. There's only one letter. I'm gonna put it on the number line. And I'm going to put a dot at -6 and a dot at 1. Would everybody see where those dots came from? Pretty obvious. Those dots should be colored in. Right? And I need to find areas of this number line where numbers produce a negative answer. Less than 0 means negative. Some numbers that I plug in will give me positive answers. I have to find the places that give me negative answers. So, what do you think I'm going to do? I'm going to plug in 0. Do I have to plug in 0? No, but I can. It's a good number to use. If I plug in 0, and 0's right in here, 0 is in this space. If I plug in 0, I would get 6 times negative 1. Does that come out to be what I needed it to come out to be?
Yes.
Yes. So that section of the number line works. I think we talked about this.
Yeah, we did.
So what can I conclude now?
The other two.
The other two don't, because we have this alternating pattern, as long as what? You don't have any of this craziness going on. As soon as you put something odd into the problem, weird, different, then you got to check every space. But as long as they're just plain old factors, you can say your answer is negative 6 to 1. That's it. So, having more factors will not be an issue. Procedurally, everything is the same. Let's try this one. Yep, these are in 2.8. This is supposed to be 17. Yeah. Now, this is a step up from what we did before. The concept is exactly the same, but before we can proceed, what are we going to have to do with this? We're going to have to factor it. Does it group? No. So what in the world are we going to do if it doesn't group? We're going to do the whole PRR thing. So see, we're just stacking layers on top of what we already know. So now we got to do the PRRs. Anybody see one that works? Let's see. 1 isn't going to work. Is 2 going to work maybe? Let's see. 1 gives me 3 minus 2 minus 1 plus 6. What is that? 6. Okay, what does 2 give me? 2 gives me 24 minus 8 minus 2 plus 6. Okay, let's try negative 1. How about negative 2? Okay, we haven't talked about this, but this is a good time to insert this idea. I've tried all my favorite numbers. 1 and 2 are my favorites, and none of them gave me 0. But I did notice that when I put in negative 1, I got a positive answer. It wasn't 0. And when I put in negative 2, I got a negative answer. Okay, now think about that graphically. If you put in negative 1, you got 2. But when you put in negative 2, you got a negative answer. Now those 2 dots, I don't know what this thing looks like, but those 2 dots have to be connected. What happens in between them? It crosses the x-axis, and isn't that what I'm looking for? So if I happen to be paying attention to this, I might try what next? Negative 1.5? Now, negative 1.5, 3 halves is one of my PRRs. Oh, no, it's not. Never mind. No, it's not. What is? Do I have one in there that is one of my PRRs? 2/3 is a PRR, but it's not between -1 and -2. Okay, that root must not be rational because I don't see it.
Might be imaginary.
Well, no, it's irrational. I'm gonna end up with some radical craziness, I think, unless I have an arithmetic mistake. I think I did this right. So I need to keep guessing. I need one. Has anybody found one yet? Let's divide and conquer, yeah. Let's have you guys try 3, and you guys try -3, and you guys try, there's no way 6 is gonna work. 6 is just too big. It's not gonna work. Can you guys try 2/3? And I'll try -2/3. And first I'm gonna make sure I copied this problem right. Here we go. Okay, so what am I trying -2/3?
It's negative 1.146272.
So -2/3 did not work. It gave me a positive 4.9. Did anybody find one that works? 3 or -3 work? I know 6 can't work, -6, those are just way too big. We have tried everything except 1/3. All right, so let's try 1/3 and -1/3. So 1/3 over here, -1/3 over here. And let's see, did 2/3 work? You guys, I didn't even ask you. 2/3 gave you something, not 0. Okay. So now we're doing 1/3. What are we gonna do if none of these work? Oh my gosh.
You gotta quit.
Well,
Did they put the problem in?
well, of course. Okay, now we're gonna talk about that in a minute, because that raises a good point. I did 1/3, it did not come out to be 0. Who did -1/3?
It didn't.
It didn't work either? All right, so let's stop right here and let's talk about some observations. Okay? First of all, when we make this list right here and we call these the PRRs, what does that R stand for? Rational. Are there numbers out there that aren't rational? Yes. Okay. So first thing is, we have no rational roots. Our roots are irrational. We're going to have to rely on our calculator to help us. Now, somebody said, I looked in the back of the book, and there is an answer. Well, we knew that already, kids. You knew there was an answer. We didn't know if it was rational or irrational, but we knew there had to be at least one answer. Because what's the degree of this polynomial? 3. At least one root has to be real. Why? Imaginary roots come in pairs. Can you have 3 imaginary roots? No. Therefore, we knew from the beginning we were going to have at least one, maybe 3, but at least one root. We went through and did all this. It's not rational. So our only choice at this point is to get out our calculators, graph it, and see where it crosses the x-axis. Now, while you're doing that, let me explain to you back in the dark ages, before graphing calculators, what we did, when I was your age taking this class, what we did was, we made this observation. -1 gave me a positive answer, -2 gave me a negative answer, so then we tried -1.5. Now, I don't know what -1.5 does for me, but let's say it came out positive. What would that tell me then? If -1.5 came out to be a positive number, where would I look? Between -1.5 and -2? Because somewhere between a positive and a negative is 0. And we had to keep just squeezing in, squeezing in, squeezing in. And before you think, oh, well, that wasn't so bad, Mrs. Ford, remember, we didn't have calculators at all. So when we say plug in 1.5, okay, plug in 1.5 without a calculator. And then we had to plug in either 1.6 or 1.4, depending on what the outcome was. So this little problem that you're typing in and pressing graph and second calc, 0, da-da-da, it's like a half-hour problem back in the day, because we didn't have a calculator. But anyhow, you've done it. What is the root? What did we come up with here? What is it? Negative 1.5.
1.15.
1.5. Negative 1.15. Does it cross anywhere else?
No.
No. What does that mean? The other roots are imaginary. Okay, great. So here's my number line. Here's -1.5. It's the only dot on the number line. Because there's only one real root, the other ones are imaginary. Does this thing look something like this? You can actually answer the question from this if you want, because you want to know where it's greater than 0. Look at this picture on your calculator. Where do the values appear to be bigger than 0? Well, there's 0 right here. Where are they bigger than 0? Everything above it. So your answer is -1.15 to infinity. Now, if you want to go back and do it on the number line, you can real easily plug 0 in. If you plug 0 in, do you get a positive answer? Yep, which tells you that side of the number line works. This problem is a little odd in that there's only one real root, so you probably should, if you're going to do it with a number line, you should probably try a number over here too. But you can tell from the graph on your calculator, these are the positive values and these are the negative ones. Boy, that was a little bit challenging and interesting. Yeah, so let's have you try one now with each other. And we'll try not to make it quite so bad. How about 15? How about 15? Try that with your neighbor. See if you can get the answers to 15. Now remember, it's not just about factoring. You're going to get it factored, but then you have to do the inequality part too. But work with your partner there, see if you can get 15.
This is what kind of restroom?
No. You got here late.
I was gonna say the same thing, but
No, let's just wait a minute, okay? You'll be all right. Which one am I doing? 15. Split up the work, divide and conquer. You only need to find one that works, so let's see. What do you do when you find one that works? Well, if yours factors, hers should factor.
No, I did quadratic.
Once you find one that works, people, what do? Divide it out, right? Has everybody found one that works? You divided it out. Now, biggest mistake that's made, and I know this because I've graded hundreds of papers. Biggest mistake that's made is whatever factor you found first and you divided it out, the leftover part you factored. For me, it was this. And kids will forget that third factor. Don't forget the number that you plugged in and got 0. That is a factor. You should have 3 factors. This is an x cubed problem. So if it factors, now our last one didn't. That last problem we didn't. So that is a different conversation. But if your problem factors, you need to have 3 of them. Not just this part. That's got to be included, whichever one you found first. All right, how do those factors look? You may have gotten them in a different order, but is that what you got? Which means that your dots are on the number line where?
-1.
-1.
3 halves.
3 halves. And 2. Oops. And they are open dots this time. And we want a positive outcome. So what do?
The number.
We pick a number and plug it in. And what number do we want to pick and plug in? 0. That's a good number to try. When I put in 0, it looks like I'm going to come out with a positive answer. Right? That's what I wanted, right? So where 0 is on the number line works. Because when I plugged in 0, either in the original problem or into my factors, I got +6. That's bigger than 0. So that section, that's where 0 is on the number line. That section works. This one won't, this one won't, this one will. So my answer is everything from -1 to 3 halves, open intervals, or everything from 2 to infinity. You okay with that? Everybody good? Okay. Next, then, we got one more kind of problem to look at, and then I'll just shut up. The last kind of problem we have to look at is something of this form. So instead of being it's another inequality, but instead of being a polynomial, it's rational. It's like those things we've been graphing. Okay, great question. Say that louder.
Could you still multiply by x minus 1 versus?
your gut feeling, my gut feeling, everyone's gut feeling, is to multiply both sides by x minus 4, and I wish we could, but we can't. Can anybody tell me why we can't? Why is it illegal? We did it a minute ago in those other problems. We did it when it's an equals, absolutely. Why am I not doing it with an inequality?
Because you're not solving for 0. That side's supposed to be bigger than 2, right?
Yes.
So it's an inequality, you can't.
I'm trying to multiply in an inequality. Are there any special rules associated with multiplying in an inequality?
Multiply by a negative.
Sometimes we change the sign, right? When do we change the sign?
Multiply or divide by
When you
negative.
multiply by a negative. Okay, wait a minute. X minus 4. Could it be positive? Could it be negative? Do I have any idea which one it is? So I can't multiply by it because I don't know whether I should leave the sign the same or change it. Now you can actually do the problem that way, setting up 2 different cases. Okay, if it's bigger than 0, I'm going to do this. If it's less than 0, I'm going to do this. It takes too long. So instead, the strategy we're going to use is this. We're going to move that 2 to the other side. Now, there's nothing wrong with subtracting. Now, I've got a fraction minus another fraction. I'm thinking of the 2 as 2 over 1. What do I do when I subtract fractions? Get a common denominator, which I think you'll agree will be x minus 4. So I'm going to multiply numerator and denominator here by x minus 4, so that now I can write one fraction. X plus 3, watch it, minus 2x plus 8. Okay, so I'm getting a common denominator here. I'm multiplying by x minus 4 over x minus 4, right? And then I'm saying, okay, that leaves me with x plus 3 minus 2x plus 8. There's another mistake right there just waiting to happen. So what is that numerator then? If we clean all that up, what would that numerator be? Negative x plus 11 over x minus 4 greater than or equal to 0? Now I'm going to put 2 dots on a number line. Anybody want to guess where I'm going to put the 2 dots? One of them's at 4 and one of them's at 11. Now if that numerator dot is giving you trouble, I think everybody can look at this and say, oh, that would be 4. But if the numerator dot's giving you trouble, then actually set it equal to 0 and solve it. That will tell you where to put the dot. All right? Now I'm going to blow your mind. I'm going to color in the 11 dot, but I'm not going to color in the 4 dot. Now some of you are looking, those of you that are still awake, are looking at the problem and saying, but Mrs. Ford, it's an or equal to problem. And in an or equal to problem, the dots are supposed to be colored in. Patty?
I was about to add on to that by saying it can't if the denominator is 0, because that's undefined.
Patty says, whoa, 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 Mrs. Ford. Denominator dots can't be colored in because if you included 4, your denominator would be 0, and that's not allowed. So no matter what this sign is, that denominator dot will not be colored in. Okay, now what am I going to do? I got my dots. Now I'm going to plug in a number, and I'm looking for an outcome that is positive, right? So if you want to use 0, you can. 0's over here. So if I put 0 in, what kind of a number would I get?
Negative.
I'd get a negative number, wouldn't I? 11 over negative 4? Okay, that isn't what I want. So this didn't work, which means this will and this won't. The alternating thing still works. So your answer is everything from 4 to 11. All right. One more, and I promise I'll shut up. I just want you to practice one more. One more of these, and then we'll do our other review quiz, and you guys can work on some homework or something. But let's do one more of these. Make sure you've got this down. Let's try 2x plus 1 over x minus 3 is, let's say, less than 3. Use that one as a model. What's going to be your first step? Subtract the 3. Fight the urge to multiply. You're never going to multiply. Fight that urge. Instead, you're going to subtract the 3. Now, that 3 is really 3 over 1. Agreed?
Yeah.
So what's our next step? Common denominator, which is going to be x minus 3. So this one is going to get times by x minus 3. So what's my numerator? 2x plus 1 minus 3x plus 9. So we'll clean it up. I've got, what, negative x plus 10 over x minus 3. Everybody good so far? Steps making sense? Now we're ready to go to the number line, right? Where are the dots going to go on the number line? At 3 and 10. The dots go at the zeros, at the x values that produce zeros. So a 3 would make this 0, and a 10 would make this 0. Now, you want to do 0 again? Pick any number you want, it doesn't matter. Oh, by the way, these are both open, right? So if I pick 0, it's out here again. What kind of a number do I get when I plug in 0? A negative, is that what I wanted? So this works, that won't, and this will. So my answer is negative infinity to 3, 4, 10 to infinity. Olivia? This is not an or equal to problem, so nothing will be colored in, since it's not an equal to. Okay, we got that so far? Everything good? At this point, you should be able to do your homework now. Okay? I think I told you, I meant to tell you, these 3 sections go really fast. We'll be having a test next week. Your homework is going to be due, your regular homework, the 2-6, 2-7, 2-8 homework, or is that right? 2-6, 2-7, 2-8 homework is going to be due our second meeting from now. So not the next time we have class, but the time after that. So I haven't figured out yet what day that is, but it's going to be that day, okay? So the next time we have class, if you have questions about homework, you can answer those. And then the time after that is when 2-6, 2-7, 2-8 is due. Okay, that's over a week away. So don't tell me I'm rushing you. I'm not. It's over a week away. You need to find the time to get busy on it. Okay? Now you're thinking, Mrs. Ford, you told us we were going to have a quiz today. Well, I thought it would be better to do these practice quizzes first, and that was just a decision I made, so we'll have to have a quiz next time. Let's do the back of this. Make sure you can do the back of this. I'm really concerned about you filling in all these blanks down here because there's no partial credit. You either get it or you don't. So we're on the back side. We're doing our practice quiz. The packet I gave you, that's how we're going to spend next week, doing extra practice and review from the packet. But here's our problem. And I went ahead and pulled a 2 out so I can factor a little more easily. And then I'm going to let you check me. Did I factor that correctly?
Yes.
Okay, something happens. What happens?
There's a hole.
We're going to have a hole. That was not in our first example, but here it is. Where will that hole be? It'll be where X is. What canceled?
At positive 3.
The hole's going to be at positive 3. That's what canceled. Now, how do I get the y coordinate? I got to graph it, folks. It's a dot on my graph. I need a y coordinate. How will I get my y coordinate?
Plug it in.
Plug it in right here. This is where I plug it in. If you plug it in back here, it won't work. You'll get a 0 in the bottom. You've got to plug it in your new problem. So if I plug in 3, what do I get? 10. So there is a hole at 3, 10. Open dot. That's how you plot it. An open circle, just like that. At the point 3, 10. Vertical asymptote. Please focus your big little eyes on the box here. Do I have a vertical asymptote? Yes, I do. It's the line where x equals 2. And that's what I write in the blank, and that's what I draw on my grid. Do we have any zeros? That's another word for X-Intercepts. We have just one this time, and where is it? -2. Your X-intercepts come from the numerator because when you set your equation equal to 0, which is what it means to be a 0, the denominator disappears, right? Boy, why'd you have your phone out? Yeah. Oh, that pink thing is your calculator. All right, good. You're allowed to have that. Okay.
Also on.
Zeros. All right, we got our zeros. Y-intercept. Do we cross the y-axis anywhere?
Yes.
Of course.
Of course we do. And where do we cross the y-axis?
At y equals 2.
Would it be -2?
The -half.
If I put 0 in, don't I get 4 over -2? Do I have an end behavior asymptote? Yes, I do. What is my end behavior asymptote? It's horizontal because the powers match. And it would be the line where y equals 2. If the power on top is smaller than the power on the bottom, then your end behavior asymptote is y equals 0, right? But if the power on top is bigger, that's when we do the division and get the slant asymptote. This one, the power's matched. So we got a nice little horizontal asymptote at 2. Now, we got a bunch of other questions to answer here, but I think we have enough to sketch the picture in. Are you seeing this? And the curve's got to contain that hole. So are you seeing that on top? So there's your picture. Full credit for the picture. Now, let's answer the questions. We got the limit as x approaches infinity and negative infinity. I know they're not in order, I don't know why, but they're not, it doesn't matter. We got infinity and negative infinity. Okay, so here we go. As x gets bigger and bigger and bigger, what is happening to your curve? Getting closer and closer to 2 from the top. That does not mean positive 2. I mean, it is positive 2, but that means 2 from the top. You're describing asymptotic behavior. What happens as you're approaching the asymptote? It's coming in from the top. Now, what happens going the other direction? Aren't we still getting closer to 2? But now we're getting closer to 2 from underneath. Now 7 says what happens as we get close to 0. And talk about x now. Here's where x is 0, right? Well, kids, it doesn't really matter whether I'm coming from the left or the right. This one says come from the right, but it doesn't really matter because whether I'm coming from the left or the right, since there's a dot there, what are my y values approaching? -2. So the answer to the question that says what's the limit as x approaches 0 is -2. From either side, it doesn't matter. There's a dot there, not an asymptote. What does number 8 mean? Find the limit of what?
2 approaching.
As x approaches 2 from the left.
Fine.
Now 2 is an asymptote. What does the curve do as you come at it from the left side? Goes down. So the limit as x approaches 2 from the left side is -infinity. Number 10 is from the right side. Well, what happens as we approach 2, the asymptote, from the right side? It's going up, positive infinity. When you approach an asymptote, a vertical asymptote, you're either going to go up or you're going to go down, right? If you're approaching an asymptote. All right, what about 3? We want to approach 3 from the left, and we want to approach 3 from the right. Okay, now we got a hole there, but I'm not panicking about that because my job is simply to say what happens to y. So as I'm heading toward 3, this is where x is 3, right here. As I'm heading toward it from the left side and the right side, what are my y values doing? Getting closer to 10. So the limit from the left and the right is 10. When you have a point, whether it's an open dot or a closed dot, when you have any kind of point, the limits from both sides are going to be the same, the y value. They're only different when you have an asymptote, right? Because it's 2 separate pictures, not one smooth. All right, so everybody good? Boy, I packed a lot of information in here. You've got about 5 or 6 or 7 minutes.
Then we have a